So if there is only one node existing, you actually cannot commit your data. Your state will not progress because you need to have a majority of nodes in your cluster come back and say, I've got the data so that it can commit its data, it to state. Does that make sense?
So by the way, this could be across data centers, or it could be trying to be a very highly redundant design within a data center, where you want to completely do it on different hardware. If you just have two sets of hardware, you have the same issue.
I'm just describing it in data center terms because it actually can happen in a data center. You have a question?
Well, I just want to try to clarify. So you have two data centers, you have two cluster of OpenDaylight.
Not two clusters, one instance.
Two nodes.
Correct. One cluster, two nodes. Or it could be like two clusters, but you could just think of it as, two nodes.
Unrelated to each other without explanation. Because today we don't have any federation between clusters or anything. So if you have two clusters, they are completely independent. One doesn't know about the other, so it size.
So, but when you refer to them as being two clusters,
No, it is
it's one cluster, two nodes. You did say there could be two different clusters.
It does not matter. There's no difference in whether these are two different clusters or this is just one node on each side. I mean, because what is a node? I mean, what is a cluster? It represents one controller, right?
Let's move to the real issue. Let's start.
Yeah. So the real issue is this won't work. So how do we make it work? This won't work because of Raft, of our use of Raft or the strongly consistent algorithm.
today.
It will not work.
Majority of the nodes be available and active. So the common majority defined as 1 by 2 plus 1. Yes. For 2 it is 2 divided by 2 plus 1, which is 2. Yeah. You need both nodes to be up for any data updates to go. If you have 3 nodes, you need 2 to be up.
No, sir, but then they are talking to each other, right?
They are talking.
Yeah, they will talk to each other as long as there's a partition. If this, this connectivity goes down, or if this node was actually down, right? In these two cases, this will not be functional anymore. It will.
You're not down to just a two-node cluster. If there was a third node, then this problem will go away.
No, it will not.
Yeah, if the third node was over here, the problem will go away. But if the third node was over here, then you still have the problem.
If you have a data center, you're okay.
If there is a partition between data center and the third node is on the data center 2 side, then C1 would work. C1 is the leader.
If you have 3 data centers, it's okay.
If C3 was here,
Data centers and
still won't work.
Basically, you're just talking network partition. It's not like the fact that they're in different data centers is besides the point.
I'm just trying to illustrate the issue that this can actually happen in a data center, more likely to happen in a data center than in a single data center, right? So if there is a partition, well, it can happen, but this still has to work. That's what people are asking for. This needs to work. So how do we make it happen is what this design is going to be about. If anybody has any ideas, you already solved this problem, I would like to hear it. But here's what I'm thinking of as a solution. So with Raft, the way it works is when nodes start up, they do an election, right? And they choose one leader. And then the leader has to get a basically consensus from its followers whenever it's updating any state, correct? So first thing we need to do is we need to stop elections. Auto elections need to stop. These guys cannot go ahead and randomly say choose like a node which is the leader. Okay, that's the first thing. And the second thing is there has to be some component, some external component which is able to decide who should be the leader of this cluster. Right? So if I have, let's say, a component, and I'll call it an elector. Now this elector is external to the controller. It's running outside. The elector does a heartbeat. Okay? And whenever the heartbeat fails, the elector goes ahead and says, is this guy the follower? If it is a follower, make it the leader. And it externally does that because now we have disabled the election mechanism. So similarly, when on this node, if connectivity fails and this is the follower, it will make this the leader. So automatically. If it is already a leader, then nothing changes. That's the design essentially. No, during isolation, well, actually, when you go from connected to disconnected state, we always toggle the state. So leader becomes follower and follower becomes leader.
You see, if this partition happened and
So is your laptop part of the cluster or is outside the cluster?
Which one?
Your laptop you mentioned, is
The,
it
the elector would be on the same host as the controller instance.
in each of the controller instances?
Yeah.
So, if there's a partition, wouldn't the elector also lose visibility?
Exactly, that's kind of my point.
Exactly. But the thing is, the elector's job is to detect that it's lost visibility and make the node like a. So, for example, let's say this. What the elector does is it's two things, right? One is, first of all, it has to let everybody outside, whoever is accessing this controller from outside, like let's say from the northbound or southbound, know that this now is the leader, right? And it does. I mean, let's say it does that using a whip. So using virtual IP, it acquires a virtual IP, and that's how it does it. Second thing is it has to say this is the leader so that its commit state can move forward. Does that make sense?
It is pinging all that laptops across.
Yes. So it pings, if it detects that, okay, it's disconnected, then it makes this the leader, it makes this the follower.
So this is preventing the candidate or isolated leader states?
Correct.
Okay.
All those things will not happen anymore. When these controller instances boot up, they will be in the follower state, and they'll remain in the follower state till the elector says, now move to the leader. This elector, in fact, if you think about it, this is actually inbuilt into our implementation of Raft. We already do that. But in this case, I don't need two votes. I need one vote only, which is this guy's vote, this elector's vote.
So, if there is a split between the two data centers, and say I have two nodes on each side,
If you have two nodes on each side, then they are,
and I want both data centers to be still responding to services,
Mhm.
then don't we need a
You want both data centers to respond to services.
because
Yeah, we haven't heard.
customer is going to one data center, other customer is to another data center.
Yeah, that is a much harder problem to solve actually.
But in fact, actually, that is what will happen, right? If there is true isolation, this elector cannot talk to that, this can, nobody can talk to this, a complete division.
Mhm.
Both sides will think that the other side has gone and they will be the leader. In fact, that's actually the more problematic scenario when they connect back.
If you acquire the whip, what happens?
See, both when they are fully isolated, both could be acquiring the web. If the router that is in front, that the client that's connecting to both,
Mhm.
that's the one which will, I don't know how the router decides.
No,
If
but,
whoever publishes the BGP,
See, when the client tries to interact with a certain IP,
it'll go to one.
it'll go to only one of them, right?
Yes.
Right. So if it, I don't think it'll go over here because this one would be the last one to acquire the whip, right?
Yeah, I mean, I guess like you said, it depends on where the clients are coming from. If
Correct.
there are some clients which are local to that data center, they will work.
Yeah.
If the client is remote, then it depends on which one acquired the BGP and who acquired the web and what is the router thing it should send to.
Yeah.
So are you saying that when there's a network partition, then your one cluster now becomes two separate clusters?
Pretty much actually.
Okay, so now the state has become destroyed. What happens if the network comes back up?
So again, what we are saying, all I'm saying is we have to somehow ensure that the state does not advance on both of these nodes. So let's say, let's go with the add flow example, right? When this guy becomes the leader and it's partitioned, I should somehow ensure that I cannot add more stuff, more data to this node.
But doesn't Akara itself can do that?
It does. But ACA Raft also requires that you need to have at least, like if you want consistency, both of these nodes should be able to talk to each other. No, later on, of course, we can. We are going. I'm not saying we are eliminating Raft altogether. Raft, we still use it for replication and making sure that they are consistent. But you have to disable the elections. You cannot let it randomly elect stuff. There are certain properties of Raft. For example, let's say on this side, right, I had 2 entries in my log, and over here I had 1 entry in my log, correct? And this guy was elected as the leader somehow. what it will do is it will actually eliminate this entry from the log. Correct? Now you still have to make this work properly, because at some point this guy was the leader, and it's whatever you put into the journal was also applied to the state, so the tree is updated and all that stuff has happened, right? So what do I do at this point? I've already told the world that okay, I have 2 flows, and now when they go over here it says, oh, well, I have only 1 flow. That's the problem to solve when you break the raft consistency. Just a second. Yeah, go ahead. Then you will lose data. Yeah. See, this is a case where, I mean, if we have to solve this, there are no good solutions. So we try to just actually come up with I'm just trying to see how can I enable this functionality. If I can tell somebody that you will lose data in a certain scenario, if they are saying, if double failure happens, for example, you will lose some data, and if it's acceptable to them, then that's good.
I think basically, see the cap theorem, until now we were saying in OpenDaylight, consistency was the only option. Meaning there was no option to say, it's okay, I can relax the consistency, I want to be partition aware. This is basically saying I'm giving a configuration option where I'm allowing it to operate when it's partition at the expense of consistency, of course. I mean, we cannot solve both. So it's kind of saying I'm giving that option, but depending upon the deployment, you could have issues of consistency throughout the code. So if that depends on, for example, when you say both data source have a proceed or not, where is the data coming from? Where are the client applications? If they're outside of these 2 data centers, then most probably only one of them acquires the web and only one of them will be actually receiving data. So it depends on where the network elements are, etc. I think it's complicated. Where are the, how is the controller getting the data?
Again, I'm just talking about enabling this stuff. This is not going to be default in OpenDaylight, so no need to worry about that. This is just a configuration option which we are going to introduce. In case somebody has this use case, they would be allowed to solve it, but using external elections. Yeah.
So, initially C1, C2, C3 are there. C2, C3 reside in one data store. C1 resides in another data store. If you can force direction such that wherever the majority controls are, that one of them becomes C2.
Mm-hmm.
The partition happens. So C1 then becomes
Problem, no, see, the problem is this. I think what you're saying is in a world where just the partition has happened, yeah, we can probably make that work. But what if both these nodes are down? There are people who want this node to continue by itself. That's what we need to make, somehow get that to work. This is not going to be a perfect solution, and I don't know whether even with eventual consistency this can be solved properly, in fact, with a double failure. The HP controller, does it actually have this? I mean, does it support this kind of mode?
I'm not sure, I have not worked on the internal project, so I'm going to tell you.
Okay, because I
Sorry.
thought they had something like this,
You may, I could find out. It's a good question.
but I don't know. I mean, I don't know how they managed it. Hmm? Yeah. I know they were trying to do something very similar actually when they were implementing. but we never moved forward because at that time there wasn't a big need for this. I mean, I don't know what you can say to customers who actually have this kind of need.
Other than disabling the election, you are also changing the commit before application.
Exactly. Exactly. It should go ahead and commit even before consensus is achieved. Otherwise, normally you have to first have consensus, then you commit. Anybody can think of a better solution?
So, sorry, I have a question. So, if you have three controllers and they all come up about the same time, so how is the election going to go? Like, is it like one of them kind of says, I'm the master, and the other ones we just agree, or?
Okay, so all three, let's just say two.
Okay,
Let's just talk about two. So we have C1, which is starting up. C2 starts up. At that time, this one is a follower. This is a default startup mode. This is also a follower. That means you can't do any transactions with this system right now.
so you default is that you follow on.
It's follower. Then you have the elector. It starts communicating with the other node. Then each of them detects, it tries to first acquire leadership. The elector tries to do that. And once it does, let's say on C1, it acquired the whip and it could become the leader, then it makes this the leader. So right now there's no partition. If there was a partition, they would remain followers. Nothing would change. Because there has to be some communication which happens first before you can determine who should be the leader. If there's no communication at startup, you cannot choose a leader. Does that make sense? Right. So now there's communication, there's no partition here. So we chose a leader and we have a follower. Right? At this point, if there's a partition, then on this node, we try to make this the leader. On this node, we try to make the follower. So when the partition is detected, this is what we should do, is what I'm suggesting.
So why do we have to do that? I mean, why don't we just let it continue
As leader over here,
and follow?
why I want to do that is I don't want this guy to accept more transactions. As follower, it will not be able to accept transactions. Or as leader, this guy will be able to.
That's okay, but what's the harm?
The transactions are anyway not going to go through. They will all fail. Each and every one of them will fail.
So you choose a leader,
Or in fact, if you kept this as the leader, it will actually accept transactions. It will move the state forward. I don't want it to move the state forward. I want only one of them to be the leader.
How do you know if C2 has not gone down after the second stage?
Over here.
Suppose C2 goes down, then what do you do?
So C2 has, so then it's different, right? So you still have leader. C2 has gone down. Now
Your detection criteria remains the same, right? Because I'm not able to communicate with that. That means I might feel that there is a partition. How do you differentiate between a partition and a node going down?
see, you could put in more logic over there. The elector, besides checking just the heartbeat, it can also go ahead and check like on the controller the JMX. Try to access it and see, okay, is it just my controller which has died? Is it just the elector on the other end has died? We can do other checks like that.
Okay.
Okay.
It is like usually to reachability to something external. Like whether that's really down or
See, what goes into OpenDaylight is just enable this functionality. This doesn't, this elector thing, business, doesn't need to be actually part of the OpenDaylight source code at all. Okay. So
Coming back to the question, over there, when we switch the leadership, and this C1, who was the leader, we changed it because we don't want transaction to fail.
correct.
And now on C2, we made that as a leader, but transaction will fail over there.
No transaction. See, as long as you're if you're leader, your transactions are going to succeed. I just don't want two leaders in the system.
Right, but
I want the transaction on one of them to fail. You see what my point is?
I think you want one of them to continue. I think his question is why didn't you even before there was only one leader, why did you let that state continue? Why did you switch?
Well, that's because there has to be a specific event based on which you change states. And what I'm saying is that specific event has to be when you notice a disconnect. On disconnect, you do something. On connect, you don't do anything.
So what's the frequency of the calling to check if your leader is up?
Yeah.
Is that something that you already determined, or we have to determine that as well?
Yeah, you have, I mean, that's up to you how you do the elector. That could be something which I built into OpenDaylight, but that's different.
So I'm a little confused here. So if you have some bifurcation of the network and loss connectivity, the premise is that you've got a loss of visibility for a portion of your infrastructure that needs controller-based services. So to me, it doesn't make any sense that you have one column go into a follower state when the leader for you can't accept the transaction. In fact, I think that both of those should be leaders so that they can process the transaction. I think you're worried about state, and I get that. The reality is that the infrastructure needs the ability to process traffic flows. So the reality is, from my perspective, is when there's a state change in which they detect there are two leaders, that's when you should have a state change where it should be negotiated that one immediately becomes the follower. That, I think, is a much more useful transition, right? So your state change now becomes, hey, we now see each other again. There's something that's rejoined our visibility, right? So the network state change has rejoined our visibility. So now someone does need to become the follower. And in fact, that's when that negotiation will happen. I think that's more.
I'm just trying to reduce the chance of data loss.
Right.
So if you have two leaders, the chances increase a lot.
I think your data loss is going to increase as well if you can't provide network forwarding because some of the other controllers gone into a follow state. Right? So you're saying it doesn't.
No, the thing is, I mean, you're using a whip, right? So all the connections to let's say you're using OpenFlow. All your OpenFlow switches are connected to your controller using a whip as well. And the northbound also you do the same thing. Well, then the connections will switch over to the leader. Now, I mean, can we let this be a leader? I mean, I don't think that will work well. That will not work because otherwise, how do you determine when should? See, there has to be one event based on which you toggle state. You cannot have two events. Otherwise, you'll be confused.
Why toggle?
Because I don't want two leaders.
Because you have two leaders, then you have to merge the logs and those.
No, what I'm saying, why toggle? If I'm not toggling, there won't be two leaders.
That is your default behavior because you
All right,
assume
so
that the leader is gone down.
so I have a partition. Okay, so this is the state.
Right.
I have a partition. It remains leader and follower.
Right.
When the partition heals, what's supposed to happen? They remain leader and follower.
Yeah.
Okay, then in which case am I supposed to actually switch leadership?
Why do you have to?
Okay, then it always remains that the way it is.
As long
How
as
do you
this
do
is
a shape? Basically,
see, that's again the point that Kamal was making. How you detect partition and node going down. So if there's a partition, why toggle? If the node is going down, yes, you have to toggle.
Okay, so your solution is as long as there's no partition, don't do anything.
Yes.
Okay, and basically even if there's a partition, do nothing.
Yeah.
Then how do I detect? See, you've got a partition, and at the same time, this leader is down. Now what you gonna do?
Don't you have that?
Don't merge. Just talk about that.
Yeah. So
No, you have to talk about both. That's what when you toggle, you can solve both.
yeah, let's go step by step.
Yeah.
So first you have a partition. Don't do any change.
Okay, so there's a partition, and you still remain leader and follower.
Right.
Okay.
Now leader goes down.
Okay, leader is down.
So you're saying there's no.
You've lost
trigger
availability.
point.
You just lost availability.
Okay. At that time, there's no trigger point to enable that to leader, right? And what happens when you do the toggle at that point?
So okay, when you do the toggle, this is what would happen.
This is follower.
This is follower. This is leader.
This is leader.
Now-
leader goes down.
No, if this leader went down, you lose availability. But the thing is, see, what I'm saying is you protect against double, like, like if there is a partition as well as I'm actually shutting this down, then this will work well.
It's the same thing.
It's not exactly the same thing. If there is a partition happening, there is a chance that it's because something bad is happening on this side. That's why we are switching over.
Well, partitioning is happening. You are saying bad is happening on the C1 side, but there's a scenario when bad is happening on the C2 side.
Yeah, but then that way, I mean, there's nothing you can do. If as soon as you switch to this leader and this is also bad,
Yes.
well,
yeah.
then you're screwed. Everything is gone.
Okay.
Or essentially what is happening is, let's say this follower dies, this whole node is down.
Right.
Okay. Now what should you do?
Then.
So you detected a disconnect. So you remain a leader
Yes.
because you're not able. Then how are you able to distinguish whether now that it should be a follower or leader? It remains a leader
Yes,
always.
it will remain
If you cannot distinguish, you remain a leader.
Yes.
Then how does the follower ever get to become a leader?
Follower doesn't have to, because that's.
If the follower never can become a leader, then how do you actually provide high availability?
But follower is down right now. Unless the leader is down, follower doesn't have to become a leader.
So on the leader end nothing changes, follower end always moves to leader. So then you have a chance of double leader.
Possible.
How do I prevent that? How do I prevent that?
Well, the scenario that you are right now saying, that also has a situation when you switch the state and the new leader which you are switching, that goes down. How do you prevent that?
No, that is an unavailability scenario. I am trying to prevent a data loss.
So let me ask, like, let's say this was a simple 3-cluster node and 2 followers went down.
Mhm.
The leader will still stop working.
Yes.
So there will be, but now what you're saying is, if the leader goes down and a new follower comes up, then we have lost data already.
In this case,
No, not in this case, in a general case, right?
if your leader goes down and your follower
And a new follower, like, and one
became
of the
leader.
followers becomes available,
Okay.
then you still lost the
No, you see when a transaction happens, yeah.
System being unavailable as data loss. You think data loss is you accepted, committed data and then you lost it as data loss. When the system is unavailable, you are not accumulating any new data.
See when once okay, it's like this. I put in some data, okay, I added 1,000 flows, and then later on I try to read it, and you say I don't have the 1,000 flows. I mean that would be bad.
that will be bad.
Yeah, I'm trying to prevent that.
And each system does not accept any data is going to maintain.
Like if I cannot distribute it.
But at the same time somehow make it work with just one node available.
So, like I know, like in MongoDB, they have this concept of arbiter.
Hmm.
That is just to give a majority for one of the sides. Yes.
You have a third place.
Yeah, it participates in election, but it's not a node which services data. So they
Hmm.
will place that.
Yeah, which is
They will place that on whichever you want to make as the primary data center.
hmm.
There is a concept you have to identify out of 4 of my data centers, one is my primary, and you assign one arbiter there, instance. So if you want to break the tie,
And
the
what-
arbiter will be the one up collection.
And if the primary goes down, what happens?
The primary goes down, the remaining, if you still have majority, one of them will become the leader.
No, but the arbiter is on the primary side, right?
Yeah.
No, I think the arbiter will have to be on the third data center.
It would have to be, yeah, if there was a third data center, we don't have a problem.
No, even in 2 data centers, let's say you have 2 and 2 on both sides.
Okay.
Arbiter will be placed in one of the primary data centers.
Okay, all right. No, I think let's talk about the specific, okay, because I think maybe you're not getting, I'm not getting how it will be different. So you have in Mongo, you have node 1 and node 2. So you have node 1, node 2. This is active. This is just standby on each side. Only this one responds, right?
Yeah.
Does that make sense? And on the other side you have node 3, node 4. Node 3 is active, the other one is just standby. It does nothing. Now let's say both these nodes go down. And what I've done is I started off, I added 1, 2, 3 items on this side. So this is up. And I modify, I add, besides the 3 which were replicated earlier, I added 2 more. Correct? Now at this time, I'll bring this down, bring up this one. What happens?
So when you say you bring that down, I mean, so there's one active on either side, right?
No, both of them were down. Both of them were, there was a partition. Now both of them are down. Now I'm just bringing up this node, this set of nodes.
Okay. So all 4 nodes went down, you're saying?
Were down at one point.
And now you're bringing which one?
I'm bringing up something which has these 2 entries missing.
No, but what I'm saying is we should prevent even those entries going missing to begin with by making sure there's only one master, right?
But I just tried to make it master, right? Because according to the Mongo model, if you're saying by adding an arbiter,
Yeah.
you increase, basically you have a majority now and you're able to write it. Yeah, I provided a majority by adding one more arbiter over here.
Okay.
So now you're able to write. Basically, like you're able to write on this end or this end, correct?
Yeah.
So now, I was able to add two entries.
Okay.
So now, instead of 3 entries, I have 5 entries. And so when you when you shut that node down and you bring up these 2 nodes, well, since it was down or partitioned, now it's missing 2 entries.
Because you're saying it's only on the other side.
Yeah, it's only on the other side. It's not copied over here.
But in this case, what we're saying is all of them went down. It's unlike the other case where you have at least one available. Right?
Yeah, so no, in this case also one was available. So initially I started off, I put 3 entries and they were replicated. Then this one went down, but this is still available, right? So, well, I was able to add 2 more entries here. So now I have 5 entries. Now I bring this one down and bring this up. Try to access the data, I'm seeing only 3 entries. So this is a data loss scenario.
See, typically, I mean, this is like disaster.
Yeah, this is a disaster.
And as nodes go down, there are things put in place to make sure it doesn't get to a state where all nodes go down and now you bring one back.
Correct. So see, I agree this is a disaster.
So I'm saying the other case where you have one node here, and you said there's a partition and one of them goes down. You can easily solve that by introducing this, like whoever, like arbiter or whatever.
No, I'll tell you what is different in my model is, if this node comes back up, I will not let it become the leader. It will still be unavailable till the other node comes up. That's why I started off. I said if you have supposed to have 2 nodes in your cluster and you bring up just one node initially and it's not able to communicate with the other node, I will never let it become the leader. Therefore, I will not accept any transactions. Well, it waits infinitely because at startup time it has to communicate.
So if you can't find the other nodes, you should do nothing.
Yes.
So there's
Again, we are talking about a disaster scenario, right? We are all agreed this is a disaster. So
So shouldn't it be like, there may be like a timeout period where it stops waiting and it gives itself the leadership role, so the system comes back up. You don't have
we could do that.
From beginning you are saying I don't need it. Then just start a single node.
yeah, it becomes a single node. Yeah.
So single node configuration is anyway available. So you can always start as a single node. Yeah.
So that's what I'm saying, that if you wait for a time and it's gonna time out and it wants to serve to the leader, and then if another node comes up, it's gonna find it on,
No, no. What you're asking for is I mean, you can do that. See, this is all external, right? I mean, we've already said that we are going to externalize this. That could be the logic of your elector, which on timeout it just goes ahead and says, all right, well, I've timed out. It's acceptable to me that this becomes the leader now, and I make it the leader and I accept the data loss.
Yes, I think the basic message is that we are externalizing so
Yeah.
that more scenarios are possible. That
Exactly.
you can tune it to your scenario, whereas today it has a fixed behavior based on the raft actor.
The part where I say when it becomes leader and follower,
It's up to you.
it's actually, I mean, I'm not going to put that into OpenDaylight. That is completely up to you how you implement that. All I'm going to do is I'm going to ensure that elections will not happen, raft elections will not happen, and there is a configuration option that you can do a commit without consensus. That's it. And then you can use it whichever ways you want to use it.
So there's one thing. So in this scenario, what if that was not allowed to write on that side, on the right side?
The writes are disabled, only reads possible.
So let's say.
That's also bad.
So in this case, let's say you put that arbiter on the left side. So you have 3 and 2.
You have one more node over here.
That's the arbiter on the left side.
Okay.
So now, if all of the left goes down, there are just 2 of them there, and they cannot write.
That's fine. Then you
They cannot write.
no.
There is no majority. So that means you said, if my primary data center is down, I don't let anyone write. But if my primary data center has a majority, it will continue to take writes. So this scenario can be avoided, where you have extra things left on the right side.
Yeah, which is the same as saying, okay, in OpenDaylight with the 3-node model, you have 2 nodes on the primary and 1 node on the backup
Correct. As long
with
as you
raft.
have- Yeah.
Yeah, and if you can convince your customers that will work for them.
But what's the difference?
Only thing is you'll have unavailability if you fail over.
So what I'm saying is one difference is 2 nodes on the one data center, one need not be a real data servicing node. It's just, it could be a very thin JVM. All it does is breaking this tie and giving the majority on one side, the primary data center.
Which is fine. I mean, I'm saying that will work. It's just that when that primary data center fails, then you will have unavailability.
I guess today we don't have a mechanism for an arbiter where it's a raft member, but it doesn't hold any data. There's no such thing.
There's no such thing. Because what would that do?
Yeah, MongoDB basically has that something like
No, but once we externalize this, you can use an external zookeeper as your arbiter. I mean, you can say, okay, who should be the leader?
What I'm saying is when Akka already has concept of this election, having another layer of election is just complicated.
No, it's not Akka which has it. It is a raft implementation that we have.
Implementation.
Yeah, but then that makes it arbitrary, right? And that actually works only with, like you are saying, you should change the logic so that you have an empty replica.
So what I'm saying is you have raft implementation, which does some election process, right? Are you saying swap that with some other implementation?
Only the election. I'm not saying, I'm saying make it external, that's all.
Is the 415 session going to start? Or
Which session?
they're supposed to run 415 cluster testing?
Sure, yeah. There you go.
I want to rush it.
No, you can take over.